So, this is moving on to the next type of reaction, which is called an oxidation-reduction reaction. In order to understand what an oxidation-reduction reaction is, you need to know what an oxidation number is. And today's the day. It's an exciting day for you. All throughout your life, I've been cranky about where you put your pluses and minus signs on your papers. And here's what I mean by that. If you had an ion, like sodium, you would always write 1 plus, right? And this right here is your charge. Today, I'm going to go Na1, or I'm sorry, it's really hard for me to write even, plus 1. And this is your oxidation number. Okay, so when you put the charge behind it, that tells you how many electrons are transferred. If it's positive, that means the electrons were transferred out. If it's negative, you brought them in. This right here is something totally different. Okay? And today's the day you learn about this. You ready? It's a fun day. So I'm going to go through the rules first so that you can understand what the rules mean. These rules on my paper might not match the order of the rules on the list that you just pulled up on your Chromebook from yesterday that says oxidation rules. This is also in the important documents folder. There's a solubility page and an oxidation number. All those rules are on the same page. Okay? All right, my favorite one. Favorite rule, number 1. Elements are always 0. So write those examples down because it's really important. Everybody thinks of just monoatomic elements, but really it's much deeper than that. It's also elements that have more than one attached. So like sulfur usually has 8 S's. Buckminster fullerene, they have 64. Chlorine has 2. The magic 7 are all in this. Any element on the periodic table. So this goes back to the good old days where you have to know the difference between an element and a compound. And sometimes elements and compounds they're the same thing. So compounds can be elements. So you have to go back to your definition of what is an element. An element is the same type of atom. Either it's the same type of atom and there's just one of them and they're sitting next to each other, or it's the same type of atom and they're covalently bonded together. Okay? So there's different allotropes of sulfur, there's different allotropes of carbon, and there's your word for the day is allotrope. Those are all elements of each other. So, for example, look at this. Oxygen and ozone. Those are allotropes of each other. They're elements, but they're totally different compounds. But what is their oxidation number? 0. And I put a line through my zeros, so you have to be able to recognize that. So when you are given a chemical formula, you have to be able to find the elements, and you have to put a 0 there. Because that is a big deal. Okay? Because that makes your life easy. Okay, next rule that I love. If you have a monoatomic ion, and you just got done with your nomenclature, which is why I held the nomenclature to this part, is because you need it so much for this and for precipitation reactions. The charge is actually equivalent to the oxidation number. So if you know the charge, you automatically know the oxidation number. Do you see how I did that? They're the same. They don't mean the same thing. they are the same. All right. Our next one is anytime you see an F, it has an oxidation number of -1. Now notice I didn't say fluoride. That's our fluorine rule. There's a fluorine rule. Then we have our oxygen rule. Anytime you see an oxygen, it's a -2, and there's one exception. There's an exception if it's a peroxide. A peroxide has a -1 oxidation number. And then if you really want to get sassy, a super oxide has a -0.5. I'm just telling you the way it is. You don't have to worry about this one, but I do want to tell you that it's there in case you go on in chemistry. So you notice this is going in trends. So I have, I'm looking at group 17. Group 17, we have a -1 here. Notice chlorine, bromine, and iodine are the same. So that's our next rule. Then we have our hydrogen rule. If you see a H, you're going to put a +1 by it automatically. So notice I see an H right here. I know that the oxidation number is a +1. I see a chlorine right here. I know the oxidation is a -1. Now, there is one exception to our hydrogen rule. If it's a hydride. So what's the difference between normal hydrogen and a hydride? Hydrides act like nonmetals. And they are a hydrogen bonded to a metal. So this is a hydride. Hydrides are really reactive. And they have a -1 oxidation number. So if you see a hydrogen at the end of the compound, and it's not an organic compound, it has to be inorganic, that's a hydride. So this is sodium hydride. And then our last rule, we're going to sum all the oxidation numbers together in a compound, and it's going to equal 0. So every compound, the sum of all the oxidation numbers equals 0. So this just ends up being a nice little math game. You really don't need to know any chemistry to do these. You just need to do some math. And the math is really easy because you're adding and subtracting and multiplying. Now, if you separate a compound into its ions and you have a polyatomic ion, then the oxidation numbers of that polyatomic ion are going to be equivalent to the charge of that ion. And those are our rules. So let's do some practicing, shall we? Shall we do some practicing? What I'm going to do is I'm actually going to give you an oxidation reduction reaction where you actually have to go through and find the oxidation values of each of the things. husband. Hi. Yeah, I made it. All is well. I'm going to have to let you go, though, because remember, I'm teaching. It's Wednesday. Okay. All right. Bye. Thank you. Yeah, he forgot I was teaching. And then he was embarrassed. Okay, so here's what you're looking at. This is the kind of situation that you're in. Notice I am balancing this for you. That's a whole nother day of teaching you how to balance these. So you don't need to know how to balance this, but you do need to know how to find the oxidation number of every single element in here. And I probably should define an oxidation number, shouldn't I? You're not going to like the definition of oxidation number. It's just going to make you angry. And I apologize for that. But the definition for oxidation number is an atom in a molecule or ion. The oxidation number of an atom in a molecule or ion is defined as the charge the atom has, and here's the bad part, or appears to have. And that's the bad part. But it's a big deal, because this reaction right here is what makes people billions of dollars. Okay? So this is called an oxidation reduction reaction, and I'm gonna be able to teach it to you after we know how to find oxidation numbers. So let's go through and find the oxidation number for every single one of these elements in this equation, because this is a oxidation reduction reaction, and I'll be able to teach you what that reaction is after we go through and find each one. Okay, so let's get our rules out, and I'm going to show you how to do this. So you ready? Okay, we're going to start right over on the left, and I'm going to look at this, and I'm going to ask myself, is this an element or a compound? Element. What do we know about elements? 0. So we're done with that one. Okay. Next, element or compound? Compound. Is it a covalent compound or ionic compound? Covalent is a nonmetal bonded to a nonmetal. Ionic is a metal bonded to a nonmetal. It's covalent, and it has a charge. So what type of covalent compound is it? It's a polyatomic what? Polyatomic ion. So let's go to our polyatomic ion rule. So I'm going to write that down here, and all of our oxidation numbers are going to be equivalent to -1. I'm going to zoom in here. Okay, now get your rules out. We're going to use them. Here we go. Do we have any rules about nitrogen? Do you have any rules about nitrogen? Do we have any rules about oxygen? Yes. Now, what is our exception to oxygen? It has to be a peroxide. Do you remember what a peroxide is? A peroxide is O2 1-. Then when you say the name of this, you say nitrate, right? Do you see how the name peroxide isn't in the name? That's your key. Okay, if you know the name of it, then the word peroxide isn't in it, then you know it's not a peroxide. Another hint that there's a 2 here. Okay? So if you're wondering what peroxide looks like, it looks like this. That's what peroxide looks like. Okay. All right. So what can I put here for an oxidation number? I automatically know it. Then if it's not a peroxide, what is it? A -2. Now I have 3 -2s. How many total -2s do I have? I have 6. So 3 times -2 is a -6. Now I have to do nitrogen. Oxygen side is done. So what plus -6 equals -1? A little bit of algebra for you today. 5. Okay, now I have to go down. If you go down, you divide. You take this number, divide it by the subscript, which is a 1. 5 divided by 1 is what? A +5. Right? Do you see how I did that? There'll be more, don't worry. You do every single one like that. So now I know N is +5 and O is -2. So that one's done. Now I move over here. Is this an element or compound? It's a compound. Ionic compound or a covalent compound? It's a covalent compound because it has a charge, right? So now I'm going to do the same darn thing, but I'm going to set it equal to 1 plus. Okay? What do we know about O? -2. How many O's do I have? 1. 1 times -2 is what? -2. What plus -2 is a +1? 3. 3 divided by 3 is what? 1. Okay, that's good because hydrogens are always +1, oxygens are -2. Did I even need to go through and do this math? No, because I could have just followed my rules. So now I can come up here and put a +1 here and a -2 there. Okay, go over here. Is this an element or a compound? It's an ion. What do we know about ions? Their charge is equivalent to what? So what is the oxidation number of this? +2, right? I'm not going to rewrite it. I'm just going to put +2 there. Okay, element or compound? Compound, right? Okay, so I'm going to write it out. NO2. Does this have a charge? First of all, what kind of compound is it? Covalent or ionic? It's covalent. It doesn't have a charge, so what am I setting it equal to? 0, right? If it had a charge, I'd set it equal to the charge because it's a polyatomic ion. This isn't polyatomic ion. This is nitrogen dioxide. Okay, now what do? Do I know any rules about oxygen? It's a 2. The name is nitrogen dioxide. That's not a peroxide then, right? So what do I do? What's my next step? And now what do? I'm going to multiply 2 times -2 is what? -4. What plus -4 is 0? 4. 4 divided by 1 is what? +4. So I have a +4 and a -2. Okay, H2. Now, do I need to do any math here? Or what could I do? Good job, +1 and -2. Okay, so you did it. You found the oxidation numbers. Now I'm going to teach you what an oxidation reduction reaction is. So here's the cool part. So this is what an oxidation reduction reaction is. Oxidation reduction reaction. Okay, now I'm going to do some abbreviating. I'm going to go ox, read, action. So now I'm going to put this over here, and I'm going to get redox reaction. Do you see how I got that? So this is called a This is called a redox reaction. Do you see where I got that? Now, this is the fun part. I love this. Okay. So, in a redox reaction, these numbers change. So let's look at zinc here. And let's find zinc over here. Did the oxidation number change? Yes. That's one of them. We got two reactions going on in one time. We have a reduction reaction going on and an oxidation reaction. So I'm just going to write this down since you told me something's happening, and we'll go back and figure that out later. Now I'm going to look at the nitrogens. I got a +5 here. Over here it's a +4. How did we get so lucky? We found the first two right off the bat. Then I have my oxygen. Oxygen's still -2. That's not changing. My hydrogen's not changing. So do you see how the hydrogens, the oxidation numbers aren't changing? And the oxygens aren't changing? Do you see that? But the nitrogens are. And sadly, this nitrogen's hooked up to an oxygen. And we're going to write this down. Okay? Now, this gets a lot more complicated. This is called a half reaction. Now, you don't need to know how to do this. Okay? But I'm showing you so you can understand it. Okay? Someday you will have to do this. It'll be easy. But look, I have to balance the charge because I can't gain or lose electrons. So this right here has a 0. This one has a 2+. So that means that this has 2 electrons right here. These electrons were sucked off of this zinc. The zinc lost 2 electrons. Okay? So if you lose electrons, you're oxidized. So this is my oxidation reaction. Oxidation. And I can't spell today. Now this one over here is reduction, because these electrons just can't pop up out of space, out of a black hole. They have to come from someplace. They're going to come from this guy. This guy right here is going to take these electrons and add it to itself and become this. And that's called reduction. Okay? Now this happens in batteries. So in my little booster pack that I showed you that I was carrying in my purse, this is right here what's making that this right here is the electricity that's going into my car battery to jump my car. And you might see me using that if you drive by with my hood up at the end of the school day when that car won't start. Because this is a relative's car that we pulled out of the weeds last night and said, I think you can drive this. Literally pulled it out of the weeds. It did not start last night. So, that's what I drove to school today, in the dark. Maybe I just didn't turn the lights on all the way. I don't know. I couldn't see it because none of the dash lights would come up. The radio did play.
Do you have it on loud then?
The radio? A little bit, because I didn't know how to turn it down. Okay, so this is an oxidation reduction reaction. Now, what do you need to understand? First thing you need to understand, how do you find oxidation numbers? Second thing is, do the oxidation numbers change? So once you find the oxidation numbers, you're going to look for that change. So you would have saw, oh, this one's changing. Don't have to go any further. You already know that this is a what? Oxidation reduction reaction. And that's the whole story. Okay? Someday you'll make these little half reactions and you'll balance them, and it'll be so much fun. But for this learning target, you do not need to know that. You just need to be able to recognize the reaction. But in order to recognize the reaction, what do you have to be able to do? Figure out the oxidation numbers. Okay. So let's try a couple of examples. Let's do this one right here. So get your little whiteboards, or you could use a piece of paper. I want you to do 45, A, B, and C. I want you to find the oxidation number of bromine, oxygen, carbon, oxygen, and this F here. Okay. Did you get done? Do you have a question as you're doing this? Please raise your hand if you're struggling, because you're going to have to do this for homework tonight. And this is a question on your test, which is why I'm really slowing down and going through it. So you're going to have a question on this where they give you, and you're like, oh, find the oxidation number of each of these elements. So 2 questions today. What was your first question? Molarity. Find the molarity of a solution. Okay, here we go. Just so for time's sake. Do you agree with me here? +6 minus 2. You see how I showed my work? This one was easy. That was a rule. 3 times -2 is -6. Oh, I did that wrong. 6 plus -6 is not -1. What is it? 5. So this should be a 5 right here. Do you agree now? Okay, that's better. Ooh, this is oxalate. I love oxalate. Fun things you can do with oxalate. This is oxalate right here. -2. Do you agree with that? 4 times -2 is -8. What plus -8 is -2? 6. 6 divided by 2 is 3. Okay. This one's easy. The charge is the oxidation number. Okay. Let's keep going. Let's do this one. This one's a hydride. This one's a hydride. Hydrides are ionic compounds. So you automatically know what calcium is. And you automatically know what the hydride is. You shouldn't have to calculate anything. Calcium is what? A 2+ normally. So that's an ion. The ion is the oxidation number. And this is a rule. So it's negative what? -1, right? Not a +1? Okay, now this one's sassy. This one's a little cranky. I'm going to do that one for you. Because this one has 3 in it. So what are we going to do? This one is silicate. I don't know if you know this, but silicate's an ion. So we got our hydrogen here. That's a +1. So that one's out. So if there's 4 plus 1s, what does the charge of this have to be? If there's 4 of these to balance out this, and I have 1 of these, what is the charge of this? 4 minus, right? I'll just show you. 4 plus what equals 0? -4. So this whole thing is a -4. So now I gotta pull it out, and I have to grapple with this on its own. So that'd be a -8. That'd be a 4. See how I did that? Now you're gonna have to do homework problems like this. Okay? Now, you'll also have to be able to do this. So we already did A here, but looking at this one right here, how do I tell if this is an oxidation reduction reaction? What do? I have to go through and I have to find the oxidation number for every single one of these. So I can just go through and write down, what's this O? -2. What's this H? +1. What's this H? +1. What's this H? +1. That's a -2. Did the H's and the O's change? No. Okay, so now I have to do the zinc. The zinc is a 2 plus. What's the zinc over here? If I have a sulfate as a 2 minus, and there's 1 zinc, it's a 2 plus. My zinc didn't change. So now the only thing left are my sulfurs. And notice it didn't change, because it's still sulfate here and still sulfate here, so it didn't get ripped apart. So is this an oxidation reduction reaction? No. Do you see how I did that? You have to know a lot of chemistry to be able to do that. And this is that chemistry literacy that I was talking to you about. Okay, so let's talk about our homework before the bell rings. We're going to double up because we have to pay for our sins from yesterday. And I'm sorry for that. So we have to do these problems. And then we also have to do problems for today, which are right here. So both types of those oxidation reduction problems. Okay? Throw in maybe some acid-based stuff. And this right here, we're obviously doing our lab, and then that day you don't come to school. So no chemistry club or no lab on Friday. You get the day off. Okay? We are going to have to put our we still have a lot of stuff left to do. See where we're at. So we call that. We are right here. We have to do stoichiometry, limiting reactants. We are pretty good at titrations, and we have to do all of and chapter 8 is something totally different than what we've been doing. It's all about gases. And I looked to see how many questions on last year's test was on chapter 8. And that's called an assessment analysis. Assessment analysis, oxidation numbers, which we did today, there's 1. Remember chemical reactions, which we've been working on the last 2 weeks, there's 10 questions. 1 balancing chemical equation question, 3 molar mass mole questions, but there's 9 questions just on chapter 8. So almost a third of your test is going to be on chapter 8, and we haven't touched it yet. Chapter 8 is easy. There's a ton of equations, but it's pretty easy. As long as you become one with the equations. And they give you the equations. Okay? There's 1 strong acid identification question. There's 1 sig-fig question. 1 balancing chemical equation question. 1 question that you have to look at it and decide if it's a covalent compound or an ionic compound. 1 question, you have to tell me how many protons, electrons, and neutrons there are. Okay, that does it for today. Do you understand what you need to do for homework? Are we coming in normal time tomorrow or 7 o'clock?
Can we do it about